Okay, so here we are back with section 6, absolute value functions. Y is equals the absolute value of x is the simplest absolute value function. To make a table to graph y equals the absolute value of x, when you plug in 0, the absolute value of 0 is 0. So you have this point. When you plug in 1, the absolute value of 1 is 1. So you have this point. When you plug in 2, the absolute value of 2 is 2. So you have this point. Now, absolute value is distance from 0. Distance can never be negative. You know that from way years past, but definitely from geometry, distance cannot be negative. So obviously, if you put in 3, you're going to get 3. If you put in 4, you're going to get 4. What happens if you put in negative 1? What's the absolute value of negative 1? It's 1. Negative 1, 1. What's the absolute value of negative 2? Absolute value of negative 2 is 2. Negative 2, 2. So what does this graph look like? This absolute value graph look like? 3, 3, 4, 4, 5, 5, 6, 6. Negative 3, 3, negative 4, 4, negative 5, 5, negative 6, 6. It goes on and on and on forever. So you draw arrows at the end. It is a V-shaped graph with a vertex. A V-shaped graph with a vertex. But that vertex can be anywhere on the graph. This is just the most simple form of the graph. With a vertex, y equals a, absolute value of x minus h plus k is called vertex form of an absolute value equation. Vertex formed. Okay, a or negative a is the slope. If a is positive, it opens up. If a is negative, it opens down. This a right there. HK is the vertex. Now, what I've seen 5 million times as a mistake is if you had y equals 2x plus 3 minus 4, in the form of the equation, this is supposed to be a minus. Right? So if that's supposed to be a minus, what made it a plus? X minus negative 3 made it a plus. So really, h is negative 3. This is supposed to be a plus. What made this a minus? Plus negative 4. So negative 4 is really k. So the vertex of this equation, you can still have the 2 here, the vertex of this equation would be negative 3, negative 4, and that you have to be very careful of with absolute value. And this form of the equation we're going to see over and over again, vertex form. This form is actually not in the textbook or online textbook. It's a form that I've used in other textbooks and in other situations that's valuable, because when we do quadratic equations, there'll be a vertex form. When we do third degree equations, there'll be a vertex form. When we do square root equations, there'll be a vertex form. So getting to know it now is very helpful. All right, so again, you have rewind for anything that goes too fast. So y equals 2x minus 3 plus 1. The 2 tells you it opens up. The 2 or negative 2 is the slope. 3, 1 is the vertex. 3, 1, it's supposed to be minus and supposed to be plus. So 3, 1 is the vertex. All right, when you see absolute value, if you don't know the very basic thing that this is a V-shaped graph, you need to watch the beginning of this again and again and again. So it's going to be a V-shaped graph from the vertex 3, 1. The slope is 2 or negative 2, but it's going up. If it's a V-shaped graph, it is going to open up, without a doubt. So you just need to know what rise and run to use in that opening up. The 2 tells you it's up 2, right 1. So if you go up 2, right 1, up 2, right 1, up 2, right 1, how do you make it a V and not a line? You go up 2, left 1, up 2, left 1, up 2, left 1, up 2, left 1. So then you end up with a perfect symmetrical V shape like that. Okay, another one. y equals negative 3x plus 4 minus 2. Now we got some stuff to deal with. The negative 3 is telling you it opens down and the slope is 3 over 1. Right? No matter what, you're going to go up or down 3 and right or left 1. The slope is 3 over 1, negative 3 over 1 type of slope. It opens down. But what about the vertex? This is supposed to be minus, so it's really minus negative 4 plus negative 2. So the vertex is negative 4, negative 2. Negative 4, negative 2 with a slope of 3 opening down. Opening down is going to go this way. So slope of 3 is down 3 right 1, down 3 left 1, down 3 right 1, down 3 left 1. And it's going to go through there and through there, and it makes a perfectly symmetrical V. Inside the parentheses you have 1x minus h. But if there is anything other than a 1 in front of x, if there is no blue there, so we'll use blue, anything other than a 1 in front of x, you have to factor that out to find h. So let's look at an example. All right, so there's the original equation. Y equals 1/2, absolute value of 2x plus 4, absolute value plus 1. All right, so what does this mean? You have to factor that out to find h. This is not h, this is k, but this is not h because of the 2. So you factor out a 2 from both of those. Very simple factoring. All right, now the 2 you have to pull out of absolute value as its own absolute value of 2. Then you have the x plus 2 here. What is the absolute value of 2? It is 2. Then you multiply the 1/2 times a 2. So 1/2 times 2 is 1. X plus 2 plus 1. So what we've done in those steps is change 1/2 absolute value of 2x plus 4 plus 1, factor out a 2, pull the 2 out, absolute value of 2 times the absolute value of x plus 2. Absolute value of 2 is 2. Okay, so we have a positive slope of 1, but then it's minus negative 2 plus 1. So negative 2, 1 is the vertex. Negative 2, 1 is the vertex with a slope of 1. So up 1, right 1, up 1, right 1, up 1, right 1, up 1, left 1, up 1, left 1, up 1, left 1. Stay focused on the fact that what you're doing is an absolute value. That's terrible. What you're doing is an absolute value function, which is a perfectly symmetrical V. So you should never see a line graph for absolute value. And there we go.